In this video, we're going to talk about finding zeros. The purpose is to be able to deal with problems involving finding inflection points or critical points. In those kinds of problems, we have to find the zeros of either the derivative or the second derivative. So let's remember how to do these things. The simplest case is when we have, say, a linear function that we can do pretty easily. Um, we can just solve the equation very easily. So suppose we have y is equal to 3x plus 2. Then we want to figure out where is this function equal to 0. So we set this equal to 0. Then we solve for x. So we have 3x is equal to, say, minus 2. And then x is equal to minus 2/3. So that's the 0. Right? It's where the function is going to be 0. Now, or it's also called the x-intercept. Zeros are where the graph of the function intercepts the x-axis. Now let's look at a more complicated example. Suppose we have y is equal to x squared minus 2x minus 3. So where is, for what x is y going to be 0? What are the zeros? We set this equal to 0 and then we solve for x. Well, in this case, we can't solve it so easily, but we can use either factoring or the quadratic formula. Let's remember what the quadratic formula is. It tells us what to do anytime we have a degree 2 polynomial or a quadratic polynomial. So we have to have a polynomial of the form ax squared plus bx plus c. And whenever you want to set that equal to 0 and find the x that solved this, well, we have this handy dandy formula that says x is equal to minus b plus or minus the square root of b squared minus 4ac divided by 2a. So let's apply that to this particular example. In this example, the a is actually equal to 1. The b is equal to minus 2. And the c is equal to minus 3. So let's plug those in to our formula, and we get minus, well, b is minus 2, so we get minus minus 2 plus or minus the square root of b squared is 4. Then we get a minus 4 from the formula. Then a is 1, so 1, and then c is minus 3. All divided by 2 times a, which in this case is 1. That 1 is right there, so we get 2 times 1. Okay, so now let's simplify. So we get minus 2 times minus 2 is minus 2 is going to be 2, plus or minus the square root of 4 minus, then we have 4 times 3, which is 12, but we have 2 minus signs, so altogether we get a plus now, 12. Then divided by a 2. Okay, simplify further. We get 2 plus or minus 4 plus 12 is 16, so we get the square root of 16 divided by 2. Further simplify, we get 2 plus or minus 4. The square root of 16 is 4 divided by 2, which is the same as, well, either 2 plus 4, which is 6 divided by 2, or 2 minus 4, which is minus 2 divided by 2. Okay, and finally we simplify, we get either 3 or minus 1. Okay, so after all that long process, what have we figured out? We figured out that the roots of x squared minus 2x minus 3, or the zeros, are x equals 3 and x equals minus 1. Okay, so that's how you would use the quadratic formula to find, say, the roots of a quadratic polynomial. We could have also used factoring. So what is factoring all about? Well, factoring is based on the following principle about, say, quadratics. Suppose we have x plus a times x plus b. Then this is the same as x squared plus, and then a times x and b times x, so we get a plus b x plus a times b. So if you write everything out, you get this. So now the point of view is if we start with something that looks like x squared plus b times x plus a times b, if we start that looks like this, we'd like to end up with something factored. So let's now put this on the other side. I'm going to switch the roles of these two things. So we want to start now with something that looks like this, and it turns into something that looks like this. In particular, what I'll do is look at the last term and see how it can be expressed as a product of two numbers, and then check whether the middle term, this middle coefficient, can be the sum of those two numbers. Let's do that in this particular example. So here I'm going to have x squared plus, and then I'm going to have a minus 2x plus, and then I'll have a minus 3. And the question is, can minus 3 be written as a product of different numbers? Well, yeah, sure. It can be written as minus 1 times 3, or it can be written as 1 times minus 3. So those are two equivalent ways to write this last constant term, minus 3. The question now is, can minus 2 be written as a sum of these? Well, if I take minus 1 plus 3, I get 2. But if I take 1 plus minus 3, I get minus 2. Oops, there's a match. I have a match between this minus 2 and the minus 2 I'm looking for here. So this pair, 1 minus 3, is going to work. So I'm going to choose my A to be 1. I'm going to choose my B to be minus 3. So I have x plus A is 1, x plus a minus 3, that's my B. So altogether I should have x squared plus minus 2x plus minus 3 is equal to x plus 1 times x plus minus 3. So you might want to check this, and so you can check this by just figuring out what this is. So I have x times x is x squared. I have 1x, and then I have a minus 3 times x, that's a minus 2x, that's good. And then 1 times minus 3 is minus 3. So everything checks out. So that's an example of factoring. Now, how does that help me find the zeros? Well, to find the zeros, we base that on had this general principle that says if I want to set something equal to 0, like this, which is the same as this, then the only way that can be 0 is if one of the factors is 0. The product of two numbers is 0 if and only if one of the numbers is 0. So either x plus 1 is 0, or x minus 3 plus minus 3 is equal to 0. Well, x plus 1 equals 0 is the same as saying x is equal to minus 1. X minus 3 equals 0 is the same as saying x is equal to 3. So these are the values of x which make x squared plus minus 2x plus minus 3 0. Notice those are the same ones that we found using the quadratic formula. So we have two different ways of solving the problem of finding of zeros of a quadratic. I'd like to note, however, that the quadratic formula is going to be more useful in more situations. If these numbers had not been integers, the actual roots had not been integers, say they were irrational numbers or even rational numbers, it would be much harder to find two numbers that multiplied together gave you the constant term, while added together gave you this middle term. The quadratic formula, on the other hand, is going to work all the time. It just works. Okay, finally, I want to point out something about this principle of two numbers being multiplied giving 0 if and only if either one of the numbers is 0. So that can be helpful in, say, factoring and therefore finding the zeros of a function like this one. So this is not a quadratic polynomial. This is a cubic polynomial. However, I can reduce it to the quadratic case by doing the following. This is the same as x times x squared minus 2x minus 1. So here I should have put an x squared. X cubed minus 2x squared minus x. I factor out the x. Now f of x is going to be 0 if either this is 0 or this is 0. So one or the other. This is 0 if x is equal to 0. Okay, so that's 1, 0. And then this is 0 if and only if x squared minus 2x minus 1 is equal to 0. For this, I can use the quadratic formula or try to factor so I can find its zeros. Once I do that, I group them together with x equals 0 to find all the zeros of f of x. Here's another example, a little bit different. Suppose we have something like g of t is equal to t squared plus minus t, or minus 1, let's say, times e to the t. What are the zeros of this? Well, again, same principle applies. To find the zeros of a product, just need to find out when t squared minus 1 is 0 and when e to the t is 0. So t squared minus 1, that's a quadratic. I can figure out when it's 0. In fact, that's pretty easy because anytime you have something of this form, it's t minus 1. Factors is t minus 1 times t plus 1. So it's either t equals 1 in this case, or here t equals minus 1. When is e to the t 0? Well, in fact, e to the t is never 0 because e is a positive number, and if you take a positive number to any power, it's always going to be positive. So no zeros for e to the t. Well, that's fine. In sum, the contributions of the zeros to g of t just come from t squared minus 1. So the zeros of g of t are equal to t equals 1 and t equals minus 1. Those are the only zeros. Nothing comes from e to the t.